Hey, what's going on, guys? Let's do this problem right here. The question is asking three charges 4 microcoulomb, minus 6 microcoulomb, and 8 microcoulomb are placed at the corners of a square with sides equal to 1 meter. How much work is required to do so? What is the potential energy of the system? So let's see how we can do this. First of all, they are mentioning this as a square with sides are equal to 1 meter, right? So let's draw the diagram. So we have a square right here and all the sides are equal to 1 meter, right? This is 1 meter, 1 meter, 1 meter. So we have three charges. You can place anywhere you want. So let's start right here. So let's choose a different color. So I put one charge right here, one charge right here. So they also mentioned it's in the corners, right? So that's why we are placing right here. So one charge right here, and we have three charges. So let's place this 4 microcoulomb right here. So this is a positive charge since the sign in front of is positive, so we know it's a positive charge, and the work done to place this one is going to be what? Since there's no another charge or another distance, the work done is going to be 0 for this one. So to place this one, so let's say this is 4 microcoulomb. Maybe, yeah, I write 4 microcoulomb right here. 4 plus 4 microcoulomb, right? So to place this one, we need energy 0. Work is 0. So let's take the another one, minus 6 microcoulomb, and let's place that one right here, right? That is minus 6 microcoulomb, and here we are going to have for work, that is potential energy. Actually, potential energy equation is K Q1 Q2 over R, right? So here if I take if I say this one is Q1, this one is Q2, this is going to be K Q1 Q2 over this distance. So let's say R, because distance is going to be same for everything. So R, so R is going to be, so K is 9 times 10 to the power of 9 Newton Coulomb square per meter square, right? No, Newton meter square per Coulomb square. Newton meter square per Coulomb square multiplied by first charge, that is 4 microcoulomb, that is 4 times 10 to the power of minus 6 coulomb, and multiply by the second charge, that is negative. So here we are going to have negative. This one is going to be multiplied by negative 6 times 10 to the power of minus 6 coulomb, and in the bottom distance is 1 meter. And if you calculate this one, you will get negative 216 times 10 to the power of minus 3 joules, right? So this is our first when we place this one. So we have one more charge right here, we place these two, we have one more charge right here, so let's place that one. So if I place this one right here, yeah, this is a plus charge, so plus charge 8 microcoulomb. If I place this one right here, this is going to be affected by these two charges, first this charge and this charge. So we had to know this distance too. Since we know this is 1 meter, this is 1 meter, we can use Pythagorean theorem to find this distance. That's going to be root 2 meter. So work done by in third log, when we place this charge, is going to be caused by, is going to be related to these two charges, right? So so the equation is going to be K Q, if I say this is Q3, K Q1 Q3 over R. So let's say this one R1. So Q1 Q3 over R plus K Q1 no Q2 Q3 over R1. So this is going to be the work done to place this one. So let's plug the values. 9 times yeah, K, maybe K common, Let's plug it. So 9 times 10 to the power of 9 Newton meter square over Coulomb square times the first charge Q1, that is 4 times 10 to the power of minus 6 Coulomb, and the 3 is going to be 8 times 10 to the power of minus 6 Coulomb divided by 1 plus this one K Q2 Q3 over R1, that is going to be 9 times 10 to the power of 9 Newton meter square per Coulomb square times Q2, that is minus 6 times 10 to the power of minus 6 Coulomb times Q3, that is 8 times 10 to the power of minus 6 Coulomb divided by the new distance, that is root 2 meter. So this is going to be root 2 meter right here, and if you calculate this value you will get 0.288 joule. This is going to be this value minus if you multiply this, if you calculate this part, this is going to give you 0.305 joule, and altogether this will become negative 0.017 joule. Now we have calculated to place each charge to the system. So finally what we have to do to find the total energy, total work required, we have to add them together and see what we get. So W total is going to be 0, the first one was 0, right? W2, to place the second one we need this negative 216 times 10 to the power of minus 3. We can also write this one as negative 0.216 joule. So this is going to be 0 minus 0.216 joule, 0 joule, and minus 0.017 joule. So if you calculate this one, negative 0.233 joules. So this is the work required to place these all three charges in this system, and that's how we do these problems. I hope you guys liked this video. See you next time.